Is everything you see, everything you are, just a projection? It's a question that sounds like it's straight out of science fiction, but today we're going to explore the very real physics behind the idea that our reality is nothing more than a hologram.
All right, so let's just jump right in. I want you to challenge, for a second, the most basic thing you think you know. Could this three-dimensional world, the room you're in, the chair you're sitting on, could it all be an illusion? Just a complex projection from some flat or two-dimensional reality far, far away.
To even begin to wrap our heads around this, we have to start with something we think is super simple: space. You know, how much stuff can you cram into it? Our gut feeling tells us one thing, but as it turns out, the universe plays by a totally different and much stranger set of rules.
You know how it is. If you want to store more stuff, you get a bigger box. It's common sense, right? A bigger library holds more books, a bigger hard drive holds more data. It feels obvious that information fills up a volume. But physics has discovered this bizarre cosmic limit on information, and it has absolutely nothing to do with volume at all.
So where did we get the first hint that our intuition is just completely off? Well, it comes from the absolute weirdest, most extreme objects in the whole universe: black holes.
So, back in the 1970s, you've got physicists like Jacob Bekenstein and the great Stephen Hawking wrestling with this really strange problem. When something falls into a black hole, what happens to its information? Is it just gone forever? What they figured out is that you can actually measure it. They called it black hole entropy, which is basically a fancy way of saying the black hole's total storage capacity, kind of like a cosmic hard drive.
And this is where they found the absolute bombshell. For you, me, this planet, any normal object, information is stored in its volume. But for a black hole, all the information about every single thing that ever fell into it is somehow smeared out and encoded on its two-dimensional surface, the event horizon. Think about that. The information isn't inside the black hole, it's on it.
Now, this wasn't just some quirky fact about black holes. People started to realize this was a deep clue about the nature of space itself. And in 1993, this weird little anomaly led two physicists, Gerard Hooft and Leonard Susskind, to propose one of the most out-there ideas of the entire 20th century.
What they said was, hey, what if this isn't just a rule for black holes? What if it's a rule for reality itself? And that's the holographic principle. It's the theory that our entire three-dimensional universe is actually just a projection. All the information that makes up you and me is encoded on some distant, flat, two-dimensional boundary. The third dimension, the feeling of depth, that might be the real illusion.
Okay, an idea that crazy needs some serious evidence, right? So, to see if it was even possible, physicists did what they always do. They built a universe on paper, a little toy universe in their equations, to see if the math would hold up.
And this is what they came up with. They call it the soup can universe. It's a theoretical space called anti-de Sitter space, or ADS for short. Now just imagine an infinitely tall soup can. The inside of the can is a 3D space that has gravity, kind of like our universe. But here's the wild part. Everything that happens inside that can be perfectly described by a totally different set of physics, a 2D quantum theory without gravity that lives only on the label of the can.
This is the famous ADS/CFT correspondence, and it's basically a perfect Rosetta Stone. It's a dictionary that translates between these two realities. You've got an event in the 3D bulk with gravity, and there's a corresponding event on the 2D boundary with no gravity. A particle falling through space inside the can? Well, on the label, that's just some ripples in a quantum field. A black hole forming inside? On the label, that's a patch of hot, glowing plasma. It's two totally different languages describing the exact same thing.
But here's the thing. This isn't just a neat mathematical trick. It's way deeper than that. This dictionary actually leads us to the most profound insight of all. It starts to tell us what space-time itself is actually made of. So in 2006, two physicists, Ryu and Takeyanagi, came up with this formula. Now, don't worry about the symbols. What's incredible is that it provides a stunningly direct link between the 2D surface and the 3D interior. It's like a recipe for how to build the geometry of space-time using nothing but quantum information. And here's what it means in, plain English. The amount of quantum entanglement, that spooky connection between particles that Einstein hated, between two different regions on that 2D boundary, literally creates a specific geometric area in the 3D interior.
Space-time isn't the stage. It's not the fundamental backdrop to reality, it's an emergent property. It's built from the web of these quantum connections on the surface.
There's this amazing thought experiment that makes this so clear. Let's say you have two regions on that 2D surface that are highly entangled. Well, in the 3D reality, what does that look like? It looks like a smooth connection, a wormhole linking them together. Now, what happens if you start to reduce the entanglement? The wormhole stretches, it gets thinner and thinner. And if you could somehow remove the entanglement completely, space-time itself rips apart. That connection is gone. Entanglement isn't like a cosmic glue. It is the glue holding space-time together.
This all leads to this incredible, mind-blowing conjecture, ER equals EPR. Basically, it's saying that wormholes, these are Einstein-Rosen bridges, or ER, are the same thing as quantum entanglement. Einstein-Podolsky-Rosen pairs, or EPR. It's wild. Einstein himself helped come up with the theories for both of these things in the same year, and he never realized they might be two sides of the same coin. That spooky action at a distance between particles, it might literally be a tiny wormhole connecting them through space-time.
Okay, so let's take a step back. What does this all mean when you put it together? It means we need a completely new map of reality, one that is way, way stranger than we ever imagined.
So let's just go over this new map. First, our gut feeling about space is just wrong. Information is stored on surfaces, not in volumes. Second, space-time isn't the bottom level of reality. It actually emerges from the deeper structure of quantum entanglement. And that leads to the third point. Gravity as we know it probably isn't a fundamental force at all, but something else entirely.
This quote from Ted Jacobson back in '95 really hits the nail on the head. Gravity is not a force. It's an equation of state. What does that even mean? It means gravity is an emergent property, like temperature or pressure. I mean, think about it. You can't ask what the temperature of a single atom is, right? The idea is meaningless. Temperature only emerges from the jiggling of countless atoms. In the same way, maybe gravity is just the large-scale effect, the thermodynamic behavior of all this underlying quantum information.
And all of this leaves us with one final awe-inspiring mystery. If our universe really is a hologram, then where is the projector? What and where is the two-dimensional surface that's projecting our entire reality? Answering that question, well, that's one of the biggest challenges in all of science.